design and develop a simple prototype modular robot joints which are suitable for the industrial purpose to do multiple functions using the same robot. Now, each individual robots has joints which could be rearranged and could be reconfigured to do a required operation. Now, each joint are mostly identical to each other, um, and each links are mostly identical to each other. The joints are basically has two links, two different types of links, which is input link and output link. In our case, the input link is a fixed link and output link is a moving part. Each links are attached with an actuator to satisfy a desired movement. Desired movement. Now, when we have there are actually five main type of joints: a linear joint, orthogonal, or we can say a T joint, which works on principle of uh, sliding motion and the linear motion, and other three joints, which is revolving joint, rotational joint, and twisting joint. They works on the principle of uh, turning or rotating or revolution uh, movements. Movements. Now, before I begin with my first joint, the material we have chose in our project is aluminum because it is best suitable material and lightweight material which can use with our actuator. Our actuator shaft dimension is 4 mm diameter and length 15 mm, and we can from our research and our uh, uh, research, and we actually did the stress analysis. We figured out that aluminum will be the best possible material that we can select for our project. Now, this is the our first link, which is linear joint. Now, as I told you before, each links has two fixed. Each joint has two links. One is a fixed, which is this one, and another is a moving. Now, the fixed joint have a same a slot, which is the length of the cutting length is 10 mm, the hole is 5 mm, and it can be detached and attached with the moving link, which is also called an output link, which has the same length of 10 mm, the hole of 5 mm, and the thickness of this one is 4.8, and same as this one has a 4.8. So you can easily detach and attach with any other joint. Now now uh, the actuator over here has an as I told you before, the length of 15 mm and 4 mm diameter. What we have done, we have attached threaded hollow screw of length 27 mm, and it can be fixed by the grub screw inserting in this part of hole. Part of hole. So we can insert the moving the output link, which is moving link of our linear joint, and when motor rotates in forward direction, the the moving part will move forward, and when we move in anti-clockwise or the reverse direction, it will help to move component in a backward direction. Now we introduce two guide pins, which which not allow will not allow to move a component 360-degree or rotary movement. This will moving component will slide on a guide pin. When motor turns, the, the moving part will come out, and when motor reverses, it will go in. And this can be controlled by using a microcontroller with a driven circuit, because the distance from the threaded part to the end, it could be like 20 to 22 mm, because the total length of the screw is around 27 to 28, and this will works on the principle of like its axis is exactly the same, or in linear joint the axes are parallel or in the same direction. Now the next joint is T joint, or in other words we can call orthogonal joint. Orthogonal joint and T joint works with same principle. Their axis is coincide with each other. In other words, they can be, it could be parallel axis or in the same axis. The only difference between those two, it has the output link is perpendicular to the input link, and in input link, and this this both of um, sliding joints or linear joint, which is T joint and orthogonal joint, have approximately same weight, and we have other three joints which are light in weight. But the amazing thing about this joint, they can still have capability to carry the weight of other two joints and any other component which is attached to it, because the motor which we are using is a high torque motor, which is a stepper motor actuator. Now in this case, it's pretty much easy design, because the fixed joint is attached with actuator, and the moving component, the moving link, sorry, the fixed link, beg your pardon, and the moving link, it's complete joint. The moving link will turn either 360 degree or 180 degree, or it can be because it can be controlled by the Microsoft controller. So it can turn in like any direction, and the motor is again, as I told you before, it's a stepper motor, so it can move bipolar direction. Now this is revolving joint. The revolving joint as works in the same principle as a twisting joint, but only difference, the axis of the both the joints are perpendicular, fixed out input link and output link is perpendicular to each other, and the fixed point is we have attached with the actuator, and it can be further tightened or fixed by the grub screw. The hole we can insert in this hole, and this will move as twisting joint. This moving link, um, 360 degree, or it will turn like in whatever direction we want, in the same with the same axis. Now we have here is a rotational joint. The rotational joint has a uh, moving part which rotates in perpendicular to the axis of the shaft of the actuator and the axis of the um, uh, fixed link. So this is just like a pendulum. You can control it in, in any degree, like if you want to move in 90 degree or 360 degree or 180 degree with any direction. And the main thing, like out of five joints, our three joints, it does a revolving motion or turning motion or rotary motion, but other two does the sliding motion, or it moves in a linear position and the thing is that it was hard to make do the design of T joint and the linear joint, because the thing we were most concerned about like weight, but thank God that like the motor was what we are using is a high torque motor, so it helps to lift the weight. Even if we connect with two more joints, it still carries the weight. Now this is basic. I selected the all joints randomly and connect with each other just to show that that our purpose is satisfied. Like if we connect any joint with any joint to do a desirable function, to do a desirable operation. Um, so if I want to use for example, I want to make a SCARA robot, so I can attach twisting with linear and linear with the rotary, or I can arrange, I can attach and detach any one of them and can create any robot. So any of these joint can be a base, can be inserted with the base, and other end can be attached with the end effector. The actuator which we are using is a stepper motor, and it can be only programmed and controlled by using a microcontroller and driver circuit, because it's not a DC motor, so it requires a circuit. And last and least, the questions.
How come you showed your drawings instead of the photographs of actual point?
The photographs of actual drawing will Anurag will show, because my part was the designing of the joint. So I did in a SolidWorks, so I decided to show in the SolidWorks. But Anurag will show you the actual photographs, and he has a component as well to demonstrate.
Sure. So you actually manufactured all of the joints?
Yes, all of the joints we have manufactured. Most of the joints we have used in a milling machine, and very few, like the square slot, it's only we have done with help of CNC machine, because it was not possible to do internal boring. So, as I mentioned before, the best thing about all the joints, the two links, the fixed link and a moving link, can attach and detach with each other. So that's the best part of a drawing.
Can you set those two, please?
Yes, of course.
Those two, don't change them, okay? The ones that you took, that was on random basis, yeah. Insert them to see if they can be freed.
Yeah.
Oh,
Like that. Yeah, it is like that. See?
okay.
Yeah, I didn't have a breakfast.
Hold one of them, showing that the other one also. Okay, it holds the other one. Am I right? That's the way. Okay. That was just a random quality
Most
control.
other ones we put the grub screw inside there. Not like that. Just you just put it inside without the grub
And
screw. No, like
I already
you put the
forgot
grub
to
screw inside
mention
that's
that,
only
like,
it's folded.
most of our joints which has moving part, it can be fixed by the grub screw, and we also did the stress analysis on that, and thank God that even if we put another joint, it won't come out, even the motor is moving in a high speed. So that's a positive thing that happened with our project.
Well, I believe we are running out of time. Am I right?
No,
Okay, one quick question.
Yes.
What is the maximum number of joints that you can actually attach to one another for a typical application?
For typical application, maximum 2 to 3.
2 to 3.
Yeah.
Mm-hmm. Yeah.
Mainly 3. Most of the robots are like that.
Anything beyond 3, I believe, provides you with a work volume that cannot be anticipated, making it really difficult for control purposes.
But in our case, the purpose was to design, like, it can be rearranged or attach or detach according to. For example, if you are using in industry a robot which can only do the pick and place. But if you want to, instead of changing the end effector, because if you change the end effector, if you put any other end, it could do the same function. But if you want to do completely different function, then remove that joint, attach other joint, and do the function. So if you want to use as a drilling purpose, you can connect the piston, remove the piston part, you can rearrange with another similar link, a joint, and use as a drilling or boring machine. So that's a basic concept and idea of project.
I have this question.
Yes.
You didn't put any approximate switches so that you can check the motion of the joint will be reach the end of the maximum size that you can move. I mean, you can just send signals to the shaft to the stepper motor and to move in the forward direction or the opposite direction.
Yes.
But you must at least added the approximate switches, check the end of both, so that you know the joint won't move out
Yeah,
of the.
that's the thing, because all our components is a circular. We actually selected the circular pattern because we can attach with in any direction,
Yeah,
and it has a slot to wire it up. Like
but if the the motion reach the end of the of the joint lamp,
yeah.
then the control will always sending voltages, and the motor will try to
Yeah. That's
move, but there's no way to move. So that means the motor will burn.
no, it won't because each actuator is connected with the microcontroller and the driving circuit, so it will work individually.
So it means there are another sensors that knows how the distance that the
Yeah,
motor.
that's why
Okay.
we go. The other partner is working. He's doing masters,
Oh, there is
and he's working
Okay.
on this. That's why our purpose was to design the suitable for the actuator and the circuit that we can put in. So we designed something like this.
Okay.
But it can be controlled. It can be programmed and controlled by the microcontrollers and the driven circuit. So it can be done. That's why I said like I can show you the my previous slide, the linear joint.
Yeah.
The linear joint, only the screw is holding this part because this is also the hollow part.
Yeah.
We did the internal threading in there and it has the same pitch of the screw and everything. Only this part can hold, but the control, if we don't have a controller, this will come out.
Yeah.
If we use only the motor. So what happens, like controller will manage the distance. Like this is 26 length of this one after this hole is 26. So we're gonna move like 20 to 22 mm distance. It will come forward and back, and it can be only achieved by the controllers.
So there is a feedback from the joints, so that the microcontroller knows
Yes.
the length of
Yeah. That's why he's going to program it.
Okay. I have another question.
Yes.
You're using a stepper motor,
It's,
but okay. But the problem is, why don't you use DC motor?
the DC motor, because DC motor can't do the multiple. Okay. With the DC motor we can connect with the battery. It will move in forward or in a reverse direction.
Okay.
But the actuator is meant for controlling, actuate the thing like we can. For example,
I'll ask you another question. I think it's easier than explained.
Yeah.
What do you think? Who can support you maximum torque? The DC motor types or the stepper motor? What do you think? According to your information.
That's stepper mode.
No. Actually, DC motor can generate more torque than stepper motor. So stepper motor are using just for the robots when you would like to work with weight load. Less weight than compared with the robots that using stepper motor, DC motor. Sorry, DC motor types generating torque more than the ones equivalent to them using stepper motor. So if you'd like to work with heavy loads, you have to use DC motors. Okay. Sometimes if you'd like to work with heavy loads, more than simple things, you have to go to the and hydraulic actuator.
Yeah, hyper.
Okay. But I'm talking about, because you mentioned that you would like to work with the high torque, so that you're using stepper motor. But actually, DC motor generates torque more than stepper motor. That's one of the problems of the stepper motor. So just the information. That's it. Okay, thank you.
Okay, thank you very much. I want to add a comment regarding what Mohammed mentioned. Actually, what they are doing is just to make the prototype.
Yeah.
The robot is not going to be used for any actual manufacturing task. So they just wanted to show.
It's just for the future. That's
Yeah.
information for the future.
They just wanted to prove that it is possible to investigate whether it is possible to make a robot, modular robot and for modular joints, or it is not. So what is important in this activity is just the idea,
Yes. That's a good one.
not the functionality of the components that we have made. Well,
Still, if someone is working on it.
Yeah, it's okay.
So,
okay.
yeah.
Just note for the future. That's
Yeah, you are right.
Thank you.
Okay, thank you very much.